Once again, I am welcoming to all of you. Uh, Today, the first question is calculate the amount of carbon dioxide that could be produced. See, we have a carbon C solid plus O2 gas, it gives carbon dioxide. We are now talking about the limiting reagent. The first question is that 1 mole of carbon is burned in air. We want to calculate amount of carbon dioxide. That means we want to calculate amount in gram of the carbon dioxide. First of all, we have to write ideal statement. According to balance reaction, we can write ideal statement. For example, here C solid 1 mole of carbon react with 1 mole of O2 produces 1 mole of carbon dioxide. Ideal statement can be written according to our requirement. See here, 1 mole of carbon is given. That means with respect to mole, we can talk. So first of all, here 1 mole of carbon react with 1 mole of oxygen. It gives 1 mole of CO2. That means we get directly answer 1 mole carbon gives 1 mole of carbon dioxide, but we need to convert into amount, that means gram. So we know that molecular mass of carbon dioxide 44 gram per mole, and here 1 mole of carbon dioxide produced, that means 1 mole of carbon gives 44 gram of carbon dioxide. This one is the first. Now second question is 1 mole of carbon is burned in 16 gram of dioxygen. In this question we will go with amount of the both reactant. We can't ignore any one. So first of all, ideal equation, according to requirement, what is our requirement? 1 mole of carbon. That means we have 12 gram of carbon. React with 16 gram of oxygen. So first of all, we will find a limiting reagent. How to find limiting reagent? See, C solid plus O2 gas, it gives CO2 gas. Listen me carefully in this, it is important topic. See, according to gram, we will write ideal statement, not according to this. 12 gram of carbon react with 32 gram of oxygen. 1 mole of carbon 12, 1 mole dioxygen, that means 16 into 32 grams. That means 12 gram of carbon react with 32 gram of oxygen. That means we need 12 gram of carbon, 32 gram of oxygen, but here only 16 gram of oxygen is given. Needed amount of oxygen is 32 gram, but given amount of oxygen 16 gram. That means compared to require, amount of oxygen is given less, and due to that this one is your limiting reagent. This one is your limiting reagent. Once again, oxygen needed 32 gram, but a given amount only 16 gram. That's why oxygen is our limiting reagent. We want to calculate amount of carbon dioxide, that means product. So always find amount of product with respect to limiting reagent. So once again we will go with ideal statement. See here, 32 gram oxygen gives 44 gram of carbon dioxide. Why 1 mole? That means 32 gram of O2 gives 44 gram of carbon dioxide. But now I have only 16 gram. 16 gram of O2 gives dash 16 into 44 divided by 32, that means only 22 gram of CO2 produced. So this is the way, according to that, first of all we have to find limiting reagent. Third question, 2 moles of carbon are burned in 16 gram of dioxygen. Once again we need to write ideal statement. See here, according to ideal statement, 2 moles of carbon, that means 24 gram of carbon is given. Okay, and we have only 16 gram of dioxygen. So 2 moles of carbon react with 16 gram of dioxygen, that means 24 gram carbon react with 16 gram of dioxygen. See here, 12 gram oxygen needed 32 gram. So 24 gram required dash, तो आपको मिलेगा amount of carbon dioxide, compare with carbon dioxygen, given amount of dioxygen, and after that write down which one is limiting reagent in this case. This one is your question number 1. Give me answer in question 1c, which one is limiting reagent, and write down amount of carbon dioxide. Now second question, see here, A plus B2, it gives AB2. Identify the limiting reagent, if any, in the following reaction mixtures. See, first of all, this one is our first question. 300 atoms of A, 200 molecules of B. See, once again I am telling A plus B2, it gives AB2. हमें सिर्फ we want to find only limiting reagent. Okay, see here, with respect to atom of A and molecules of B, first of all we will write ideal statement. So how to write ideal statement? See here, one atom of A reacts with one molecule of B, 1 1. Okay, so 300 atoms require dash, so 300 molecules of B2 is required. According to our first question, needed amount of B2 300 molecules, but see here, given given proportion of B with respect to molecule 200, so required 300 but given 200 molecule, that means this one is your limiting reagent. This one is your limiting reagent. Now second question, see, 2 mole of A react with 3 mole of B. Now we will write ideal statement with respect to mole. A plus B2, it gives AB2. See here, 1 mole of A, 1 mole of A react with 1 mole of B2. Okay, this is your ideal statement. But the given amount of A is 2 mole. So 2 mole of A require dash. So we will get 2 mole of B2. So require moles of B2 2 and given 3 moles. That means require 2 moles but given more than 2 moles. Okay, we need 2 moles of B2 but given 3 moles. That means given amount is greater than required. So in this case your 2 mole of A is limiting reagent. Okay, now third one, C. 100 atoms of A and 100 molecules of B with respect to atom A and molecules B. So A plus B2, it gives AB2. Once again we will write ideal statement with respect to atom for A and with respect to molecule for B. So one atom of A reacts with one molecule of B2. We have 100 atoms of A, 100 atoms of A. So needed molecules of B2 dash. So 100 into 1, that means 100 molecules of B2. See here, whenever you have 100 atoms of A, you need 100 molecules of B2. And in the question, 100 molecules of B is given. That means required amount is equal to given amount. So no one is the limiting reagent in the given this question C. Once again, I give you hint with respect to mole for A and with respect to mole for B. In this question D, write down ideal statement and write down in comment box both of the answer. Now this one is interesting. See, 50 kilogram of N2 gas and 10 kilogram of H2 gas are mixed to produce NH3. Haber process. N2 gas plus H2 gas, it gives NH3 gas. This is not in a balance form, so write down here 3, write down here 2. Now this one in the balanced form. First of all, in the question, calculate the amount of ammonia is asked. So we want to know calculate of product. So first of all, see, amount of both the reactant is given. So first of all, we have to find limiting reagent. See, this one is given kilogram, so we can easily convert into gram. N2, we have N2, that means 21 mole of N2 according to reaction, 1 mole of N2. So that means 28 gram of N2 reacts with 28 gram N2 react with 3 2s are 6, that means 6 hydrogen atoms, 6 gram of hydrogen, 6 gram of hydrogen. we have 50 kilogram of N2. That means 50 into 10 raised to 3 gram of N2 is given. So 50 into 10 raised to 3 gram of N2 require dash amount of hydrogen. So calculation 50 into 10 raised to 3 into 6 divided by 28. So I need calculate this time. So answer is 10.714 into 10 raised to 3 gram of H2. Required amount of hydrogen is like this, and the given amount is, see, given amount of hydrogen is 10 into 10 raised to 3 gram. So require 10.714 and given 10 into 10 raised to 3. That means hydrogen is your limiting reagent. Okay, limiting reagent. Now we need ideal statement. See here, 6 gram of H2 gives 34 gram of ammonia. 34 gram of ammonia. Why? 2 into 17. Okay, 34. But we have 10 into 10 raised to 3 gram dash. So 10 into 10 raised to 3, that means 10 raised to 4, 34 divided by 6. So write down, do calculation yourself and write down in my comment box. Now dinitrogen and dihydrogen react with each other to produce ammonia according to following chemical equation. That means N2 gas plus H2 gas. This one is not in the balance form. Write down here 3. So N2 gas plus 3 H2 gas, it gives twice NH3 gas. Calculate the mass of ammonia produced when 2 into 10 raised to 3 gram dinitrogen react with 1 into 10 raised to 3 gram of dihydrogen. Once again, amount of the both reactants are given. So first of all, we will find limiting reagent. See, ideal statement according to gram, 28 gram of nitrogen reacts with 6 gram of hydrogen. Now we have amount of ammonia 2 into 10 raised to 3. 2 into 10 raised to 3 gram of N2. Chalo, required amount of hydrogen is dash. So 2 into 10 raised to 3 into 6 divided by 28. I have no time, so I did calculation 0.4285 into 10 raised to 3 gram of H2. See here, amount of required amount of hydrogen, dihydrogen 0.4285 into 10 raised to 3 gram. But the given amount of hydrogen, see here, 1 into 10 raised to 3 gram. That means given amount is greater than required, 1 point something, and here 0 point something required. So this one is not your limiting reagent. So we can say now your nitrogen, where is this one? This one is your limiting reagent. Limiting reagent. So now according to given amount of dinitrogen, we can calculate the amount of ammonia. How? See, equations, 28 gram of N2 gives 2 moles of, that means 34 gram of ammonia, but we have 2 into 10 raised to 3 gram of dinitrogen. So 2 into 10 raised to 3 into 34 divided by 28, 2.42 into 10 raised to 3 gram of NH3. Now second question is, will any of the two reactant remain unreacted? See, proportion of the given amount of hydrogen is in excess, required 0.4285 into 10 raised to 3 and given 1 into 10 raised to 3. That means yes. If yes, which one? That means which one? Now you know, H2. Okay. And what would be its mass? That means how can we identify? Given 1.0 into 10 raised to 3 minus required 0.4285 into 10 raised to 3. Okay. So 1 minus 0.4285 into 10 raised to 3 gram of H2. Calculate it yourself and if possible write down in comment box. Now calculate the mass of sodium acetate. This one is sodium acetate. See, I think you know about it. Calculate the mass of sodium acetate. This one is sodium acetate, CH3COONA. Require to make 500 ml of 0.375 molar aqueous solution. Molar mass of the sodium acetate is given. No need to calculate. So calculate mass. But see here, molar, that means molarity is given. First of all, write down formula of molarity. Molarity is equal to mass of sodium acetate, CH3COONA into 1000 divided by molecular mass of sodium acetate into volume of solution in ml. So molarity is given 0.375 is equal to mass X, because we want to find, into 1000 divided by molecular mass 82.0245 into volume of solution in ml, see, 500. So X is equal to 0.375 into 82.0245 into 500 divided by 1000. So amount will be like 15.38 gram. Okay. Next one is so much interesting. Both. Calculate the concentration of nitric acid. Calculate the concentration of nitric acid, that means mole per liter, in a sample which has a density 1.41 gram per ml. See here, listen me carefully. And the mass percent of nitric acid is being 69%. Nothing is written after 69%. So many students have a confusion like this. See here, 69% W by W. Why? Because mass by mass. That means 100 gram of solution. 100 gram of solution contains 69 gram of nitric acid, HNO3. This is the meaning of this 69% W by W. So you have a mass of solution, you have a mass of solute. We want to calculate concentration, that means molarity of HNO3. So you know the formula, required mass of HNO3 69 into 1000 divided by molecular mass of HNO3 63. Now volume of solution is not given, but we have a density of the solution. See, density of solution is equal to mass of solution divided by volume of solution. Density 1.41, mass of solution 100, volume of solution. So volume of solution is equal to 100 divided by 1.41. That means we will get answer 70.92 ml. This is the volume of the solution. Write down there 70.92. So you will get answer 15.44. कैपिटल है बिकॉज मोलारिटी. नाउ आई वांट टू से यू समथिंग. बहुत सारे बच्चे ऐसे हैं जिसको इस सम में बहुत प्रॉब्लम आती है. क्यों पता है? उसकी पहली मिस्टेक, उसकी पहली गलती, वो आधा लिखते हैं डेंसिटी इज इक्वल टू मास बाय वॉल्यूम. तो उसे ये पता ही नहीं रहता कि डेंसिटी किसकी है, मास किसकी है, वॉल्यूम किसका है. So I give you advice that whenever you are doing this type calculation, like this type of calculation, पूरा लिखो. आप पूरा नहीं लिखते इसलिए फंसते हो इसमें. अब देखना, अब नहीं फंसोगे. और ये जो था ना, ये मैंने नहीं कहा है फर्स्ट लेक्चर में, पर इसका एक ध्यान रखना कि परसेंटेज वेट बाय वेट, इसका मतलब ये होता है मास ऑफ सॉल्यूट divided by mass of solution into 100. अब देखो यहाँ 1000 नहीं लिखना है. मोलारिटी, नॉर्मालिटी, फॉर्मालिटी, मोलारिटी अकॉर्डिंग टू दैट. नो, दिस वन इज अ परसेंटेज. सो मल्टीप्लाई बाय 100. फिर भी दिक्कत आती है तो मुझे इन्फॉर्म करो.